Okay, welcome back everyone. In this episode, I'm going to work on the legs for the welding table, and then hopefully, if all goes well, get it sandblasted and painted all in this episode. But if not, there'll be one more after this one finishing up. So in regard to the legs, if you remember in the last episode, I wasn't sure what height it was going to be, so I kind of used my table saw. I'll pan down here. I kind of used my table saw as a good point of reference. If I was standing, this for me, I'll scooch back here so kind of you can see. So if I was to stand and weld, this is comfortable. I'm not leaning over. As you can see, I can do this. If I needed to get a little closer vision-wise, I can still lean over. So this is a comfortable height for me from a standing perspective. And then if I was to sit in a chair, I can always get, for TIG work, I can always get a taller chair too. This is also a very natural height for me to hold a TIG torch with. So I'm going to go with the same height as the table saw, which is 36 inches. So just doing some quick calculations here on a piece of scrap cardboard. Don't know how well that'll show up, but so if I've got my 36 inches from the ground to the very top of the table, I have to subtract, the legs will be touching the bottom of the table. They won't go up inside the tubing. So I have to subtract the 2 inches at the top. I'm going to add a piece of 3/8 inch plate that'll have a hole tapped, and that'll allow, and a jam nut that'll allow me to adjust the casters a little bit for unevenness if I need to. Then subtract that 3/8, and also the caster height to where its mounting nut would be is 5 1/4. So I add subtract that also. So that gives me my total length. And I've been doing enough construction and stuff for a long time. Fractions in my head are pretty easy, but if any of you haven't seen it and you deal with fractions a lot, especially if they're oddballs, I thought I'd show you this calculator I have. Get in there close enough where you can see the brand and stuff. And it's nice because it works as a normal calculator, but it also works in fractions. So let me see if I can get you a close-up here. Okay, so as I mentioned, the 36 inches is the total distance. So if I could do it two ways, I could take the 36 and subtract. So that's what I'm going to do. So on this calculator, it's just a matter of putting in your value, hitting inch. You can see on the display then that shows 36 inches minus, I know I have to take the 2 inches away, so 2 inch, subtract again. That gives me a running total of 34 so far. Then I also have to take out the 3/8 of an inch. So I'd already done the minus, so 3, and then you just use the slash to give it 3/8 of an inch, as you can see there. Subtract that. The caster is 5 1/4. So 5 inch, 1/4 inch, subtract that, and then, so that's 28 3/8. Is the total length that I need to cut the tubing. So anyway, if you do a lot of fractional stuff and you don't want to try to do it in your head or convert from a decimal, that calculator comes in kind of handy. So really the only work I've got to do here is cut those legs down. If you recall, I showed you that these legs, I picked those up from where I pick up my scrap steel that were already made. I was going to use this original pad that was already on the bottom, but when they welded it, it's not the flattest. You can actually kind of see there that it's got a little bit of angle. Plus, it already had a 1/2 inch hole in it, which if I didn't want the casters to be adjustable, that would have been fine because the caster just drops right in the hole. I would have had to cut a little window here in the tubing to get in there and put a nut on it and bolted it down. It would have worked fine, but where I want these to be a little bit adjustable, and this is only 3/16. That'd be borderline enough threads to hold the weight that potentially will be on this. So I'm going to replace this with a piece of 3/8. I could just some 3/8 on top of it. But then I have this fairly big square that almost gets in the way of putting on the brake. So I'm actually going to cut the length of tubing I need from the other end. So I'll cut from this end back the length I need, cut those off. I'll weld that piece of 3/8 thick 2-inch flat stock that has the tapped hole in it onto there. Again, cut a small window so I can reach in there with a wrench to tighten the nut. And so anyway, that's really all the cutting that needs to be done, and then it's just a matter of setting them up on the table, getting them plumb in both directions, and weld them down. So let me get set up here at the saw, and I'll bring you right back. Okay, so I'm just in the saw. I've just got a piece of 2-inch wide, 3/8 thick flat bar set up. I'm going to cut out 4 2x2 squares, and then I'll cut the legs to length after that, and then I'll set up those squares in the drill press to drill them. That was a real time cut, so that gives you an idea of when, if you've seen me cut the wider stuff in the past and you have that really large surface area for the saw to plunge down through, how much that slows it down. So that piece of 3/8, again, that was a real time cut, so it cuts through. When you're cutting like this and you don't have a real wide surface, it mows right through it. I'm going to scoot you over here and show you what I had to do, because the feet, the piece I need to cut off here lengthwise is such that instead of this wider foot being out past the fence, it comes into the fence, so that's going to hold the piece off there. So clamping it, of course, would be a challenge, because as you clamp it, it's going to try to swing it in. So they have this foot offset evenly 1.5 inch all the way around. So I just grabbed a piece of 1.5 inch square tubing here, and then also on this end to support it. That keeps this piece relatively square in regard to the blade. And so when I clamp it down, like I just did there, when I clamp it down, I'm clamping it against, still this against the tube, and then the tube against the fence. So I still get, it's still super stable, and that way it's not gonna grab and try to jump out of there. I could tell as soon as I started cutting those that as thin wall as that is, it should have just went through that, and they're cutting really hard. So I see now why maybe they were the scrap thing, it's hard to say. But even though those are powder coated, they're stainless. And I'll grab the magnet real quick, and there is even the foot, 0 stick. So I'll probably finish doing them. It's kind of hard on the blade. It'll cut stainless, but to do anything with stainless, whether it's drill it, anything else is kind of hard on cutting edges. So we'll see how it goes. Those blades aren't super expensive, but they're not cheap either. And that one's fairly new, so I might switch over to a cutoff wheel. We'll see how this first one goes. I'm going to switch over to the cutoff wheel because I just don't want to wipe that blade out. I might try it on the bandsaw blades for the little porta-band. Those are pretty inexpensive, so I might try a cut on that and see how that goes. If that goes a little bit better. I just hate cutting stuff off with a cutoff wheel because it takes longer and makes a lot of sparks. So let's see how this goes. Okay, that went well. So I'm going to get the others. All marked out. So I'll have some lines to follow and get these all cut and bring you back. Okay, I got them all marked out. I'll just bring you guys along as I make a full cut through one and see how that goes. And if it goes well, then I'll just get the other two knocked out off camera. Similar principle applies when you're cutting through material, whether it's with the chop saw or a metal bandsaw or whatever you have. Anytime you have a large surface area, it's going to take longer to cut through unless you have a real aggressive blade, i.e. quite a few less teeth per inch. So in the case of this, since I'm freehanding it, if you start on the corner, then that lowers the width of the metal that you have to cut through, and it usually cuts a little bit better. So let's see what happens here. That went actually way better than I thought it would do. As you see in there, I kind of just did a rolling fashion, and that way I marked it on all four sides, but that way I could make sure I followed on my line really close to keep them as square as possible. So I'll bring you back after I get the other two done. Okay, now that I got all those legs cut to the proper length, I'm going to get those plates that I talked about that'll have the 1/2 inch 13 hole tapped in, get them drilled and tapped and get them welded on. So I just pre-marked out the holes, the centers on those plates. So we'll get those drilled. 1/2 inch 13 is a 27/64 drill bit, so we'll get those drilled out here and get them tapped. I'll get that drill press slow down here. I'll power tap these, so I'll switch to a different speed and bring it back. Okay, I switched over to the other drill press. It's got quite a bit lower speed, which is a little bit better for power tapping. So I'll pan you down here. You could do this certainly do this with the tap wrench, but this way it kind of confirms that the tap will be nice and straight. And with a 1/2 inch tap, it's really unlikely to break the tap. So I just turn it on, and once it's engaged about as far as I want, shut the power off. It'll make a few more revolutions, and I wish it had reverse, because then that would be easier, but then I'll run it out by hand and do them one at a time that way. Okay, that's all of them tapped to half 13. Let's see how they fit one of the casters. Yep. So I was going to put this up inside the tube, cut a window in the tube to have the jam nut on the inside to make them a little lower profile, but that's a lot of extra work. So I think I'll put so I don't have to cut a window in the tube, I'll put the jam nut on the bottom side, and that way I can still adjust them to where I want, tighten the jam nut down, and that'll save having to cut a window in each one of the legs. So I'll get the powder coating off of the legs here, and we'll get it set up and we'll weld them. We'll talk a little bit about that process, since I am going to weld mild steel to the stainless. So stand by here. Whoever had ordered these made must have paid some pretty good money, because underneath the black, what I assumed was powder coat, it may not be. The finish wise, it almost looks like it was spray, but there is, I'll bet you, 5 or 6 mils of the black, and then you can see it there. There's also a good 5 or 6 mils of a primer sealer on there. So somebody paid some pretty good money to have these manufactured just to end up at the scrap place. So go figure. All right, so the paint's cleaning off of those. They're basically just, that fleece is going to go on the end. Given it's pushing down, because the weight, I'm not going to worry about getting carried away with welding it all around. I'll just do probably a stitch, an inch or so long stitch on each end. Given the Azar stainless, let's talk about stainless and welding stainless here for a little bit. If these pieces were stainless, and obviously the legs are stainless, the correct way to do it would be to weld them with stainless wire, which, if you're going to do stainless wire, that means you use what's called a trimix gas. It has helium in it also. But I mean, I don't formally know what, if this was going to be in a structural capacity or something. Mixing the two dissimilar metals may not be an approved, but I've welded plenty of stainless to mild steel and mild steel to stainless. You could do it with either wire and either gas. If you don't use stainless wire and the trimix gas, the weld bead would rust, of course, but I'm going to paint this, so ultimately that doesn't matter. The other thing, if I was going to do a lot of stainless, I would set up a little bit of ventilation, or try to set up some ventilation, because when you're welding stainless, it creates hexavalent chromium, which is not good for you. So what little bit I'm going to do here won't be that big a deal. I'll try to not be hovering right over the welds and their short tack. So just something to keep in mind from a safety perspective if you are going to do stainless, to try to think about. Especially welding isn't as bad, but if you're plasma cutting or things like that, when it vaporizes the metal into a liquid, and then that chromium gets in the air and you breathe it in, it's not good for you. So let me get set up here. These would be a little tricky to clamp. I might try it with a bar clamp to hold them on there square, because I could just set them like this. They are cut square enough that they would balance. It's because this is wiggling. But to keep them from pulling, as soon as I tack weld it on one side, it's going to want to, so for instance, if I tacked it on this side, it's going to want to do this. That's exaggerated, obviously. So I might set up one bar clamp just so I can clamp them, and that way there's no chance that they wiggle around. Okay. I'll scoop you guys over here, keep a better angle. There's one down. I won't bore you with doing the other three. It'll just be a rinse and repeat, and then we'll get the table flipped over and I'll show you where I'm going to put those in position. Okay, I got, as you can see there, I got it flipped over, bottom side up. And it's pretty straightforward. The legs just sit here in the corner. I will have to either notch this out a little bit, or when I tack this all together, there's some tack welds on this inside edge here, so that's not going to let it sit nice and flat. So I probably will notch the leg out so that way I'm not taking away the weld. And this surface here will act as a good way. If you recall, I squared this with the face, so that'll be a good clamping surface here that'll hold the leg really square in this direction, and all I have to do is worry about squaring it in this direction, and I can tack them in. So one at each corner, obviously, just set them there and weld it. Same thing, I'll take off a little bit of powder coating in the 3 different spots. I'll weld it or tack it heavily. And so let me get one of these notched out, and I'll show you how the fit is, and then we'll go from there. All right, let me move you here. So it's just these weld beads here were what was in the way. So I just notched the tube out to clear those. So that now will sit right there in that corner. One little tiny spot that's touching where the bead's sticking up higher than it needs to be. Clamp it up here just roughly and see how square it is. Alright, it's not squared off this way, I can already see that. I guess it's square there. Let's see how. Scoot you guys over so you can also see. Trying to get the angle about right. Yeah, it's not quite. It's going to have to come out a little bit, so yeah, I can see where it's hanging up a little bit, so I'll get that taken care of. And still got to again clean the powder coat off of those where I'm going to weld them. And so I think this is probably maybe a good spot. I did a little bit of editing. I think I'm pretty close to half an hour because I was hoping to get this one fully assembled, sandblasted, and painted, but I don't think that's going to happen. So I think I'll wrap it up here, and then in the next episode I'll have the legs on, really, which is about all that's left, and then I'll show you some bracing I want to do, and then definitely in the next episode we should be able to finish it up. So if you like my content, like, subscribe, and comment, and that helps me keep motivated to keep doing this. Thanks.